Hello again. Now in this lesson we are going to talk about the voltage temperature imbalance diagnostics. Now let's understand this lesson very carefully. Okay, I'll take a pointer. In the context of battery diagnostics and troubleshooting for EV connected vehicles, the voltage and temperature imbalance diagnostics play a very critical role in maintaining safety, longevity and temperature of high voltage battery system. Now, these imbalances are often early indicators of deeper issues at the cell, module, and pack level and are closely monitored by battery management system and connected vehicle infrastructure. Now, talking about what is voltage and temperature imbalance, the voltage imbalance occurs when individual cell voltages deviate beyond acceptable thresholds. Understand this sentence very carefully. This voltage imbalance occurs when individual cell voltage deviate beyond acceptable threshold from the average voltage of the series connected group. A small voltage spread is expected due to cell variation. And talking about the excessive imbalance, example greater than 20 to 30 millivolt can lead to overcharge of the weak cells and reduced usable capacity, accelerated degradation. All right. Now talking about the temperature imbalance, it occurs when temperature sensors across the battery pack report uneven heating or cooling, and it leads to uneven state of health, localized aging, safety risks, etc., etc. Okay. So understand this difference clearly between the voltage imbalance and also the temperature imbalance. Now, what are the major reasons or major causes of the imbalance? The first is the cell quality variation. The cell quality variation, and this cause leads to voltage imbalance, and the reason may be manufacturing inconsistencies, varying internal resistance and heat generation. Talking about the aging degradation, capacity fade or increased IR in some cells. It increased heating under the load. Now talking about the balancing circuit fault, passive active balancing failure, and when it comes to temperature imbalance, it is not acceptable. Talking about cooling system issues, voltage imbalance, well, it's not applicable. But when it comes to temperature imbalance, uneven coolant flow can lead, and also air blockages. Talking about the sensor faults, the voltage imbalance can be because of misreported voltage, and temperature imbalance can be because of incorrect thermal readings, wiring and connector faults, high resistant joints, and localized heatings. All right. So these are the various types of imbalance that are caused and all causes of imbalance and the reasons for voltage imbalance and the temperature imbalance. Now talking about the diagnostic strategies in EVs, the cell voltage imbalance detection, and what are the various types of methods used by BMS. Now talking about the real-time monitoring of individual cell balances, the compute cell voltage spread, the computer and thresholds typically between 20 millivolts for new packs and alarm at 50 to 100 millivolts. Now talking about the monitoring during discharging, charging, discharging phases gives best insights. Okay. Now talking about the DTCs, P1A10, P1C73, and P1C74 are the various DTCs that are popped up during the due to cell voltage imbalance. Okay, the first one is cell voltage imbalance detected. Second is individual cell voltage and individual cell under voltage. Now talking about the symptoms, the premature charge cutoff, uneven state of charge readings, and reduced usable capacity, and warning lights or derating. So these are the various methods used by BMS to detect the cell voltage imbalance. Now talking about the temperature imbalance detection and what are the methods used by the BMS. The sensors on each module or cell group, they compute the sensors on each module or cell group. First is it computes the temperature difference, T max minus T min. This is an elaborate formula, so I will not go into it. So just understand there is a mathematical formula which is computed and based on which the temperature imbalance is detected. And also threshold, typically greater than 5 to 10 triggers warning, and it also monitored during the charge, discharge and ambient soak conditions. Now, talking about the DTCs, P0AFA battery thermal management fault, P0AA6 battery cooling system performance fault, and talking about the symptoms, reduced power availability, BMS initiated thermal cutbacks, and potential safety risk if not mitigated. Okay, so these are the various types of temperature imbalance detections. Now, talking about the advanced diagnostic techniques, the first is the passive balancing feedback, which is, and to elaborate on this technique, it monitors how long BMS tries to balance a specific cell. All right. Now talking about an example, cell needing longer balance. It means that it is weak. Now talking about OCV SOC mapping, comparing cell voltage to expected SOC. All right, comparing cell voltage to expected state of charge. Now talking about an example, divergent behavior indicates degradation. Now impedance resistance estimation, estimate internal resistance for each cell. Okay, now the example is higher IR, higher heat and faster degradation. Now talking about the cooling flow mapping. Okay, this is a very commonly used technique to check the temperature imbalance detection. The description is use temperature plus pump sensors and uneven flow to localized heating. Okay, so these are the various elaborate description of the temperature imbalance detection. Now, what are the roles? What are the role of connected diagnostics in this whole scenario? Where do diagnostics come into picture? So, connected EV platforms continuously collect voltage temperature data and analyze it via cloud analytics. Now, talking about the cloud-based functions, identify persistence imbalance trends, and it also predicts the cell module failure. It also notifies users or fleet managers. It enables VOTA updates to balance thresholds or cell modeling. Okay, now talking about the visualization tools, heat maps or cell module temperatures and voltage deviation graphs, alert dashboards for field technicians. Now these are the visualization tools, how various imbalances are visualized. Okay, so to summarize, troubleshooting approach for imbalance. First step is you have to read the DTS and you use and the corresponding action is use UDS or OBD scan tools. Now talking about the analyze cell voltage spread, it look for persistently low high cells. Now review thermal maps, identify hot or cold modules, and coming to the test balancing circuit, the corresponding action is check if balancing is functioning. Next is measure IR. IR use the impedance tool or BMS model. Talking about check cooling system, the action is flow rate, pump status, coolant leaks. And talking about the validate sensor health, it replaces the faulty sensors or connectors. Okay, so these are the various troubleshooting approaches for the both voltage and temperature imbalance. And the remedial actions is for the fault type. We will talk about remedial actions for every fault type. So for cell voltage drift or voltage imbalance, the fault type, the possible solution is replace cell module, reflash BMS balancing map. And talking about the thermal hotspot, fix cooling block, replace module or coolant system. For balancing circuit failure fault type, you replace the module PCB, printed circuit board or BMS slave. For sensor anomaly, you replace the sensor or retighten connector. And talking about the aging cells, apply SOH correction map, schedule replacement. So these are the various fault types and these are the various remedial actions. Now talking about the summary table. Okay, we'll talk about the imbalance type, the threshold, the risk, and the diagnostic method. When voltage it is greater than 30 to 50 millivolt, the risk is the SOC error, the overcharge, the cell aging. And diagnostic method is BMS live data or diagnostic trouble code. Now talking about the temperature, it is greater than 5 to 10 degrees, 10 degrees centigrade, and risk is safety risk and SOH degradation. Now thermal mapping sensor data. Okay, this is the diagnostic method, and persistent cell deviation, imminent failure, and voltage logs and cloud analytics. Okay, these are the diagnostic methods. Okay, so hope all of you got a fair idea about the voltage and temperature imbalance and the various corrective actions and also the possible causes. Thank you.